Assalamu alaikum students, hope you all will be fine. This video is the continuation of the last video on differential equations, in which we have discussed that what is a differential equation, what are the kinds of a differential equation, and what is the degree and order of a differential equation. Now today's video is particularly on ordinary differential equation. We will discuss some other properties of ordinary differential equations, in which the first name is initial value problem and the second name is boundary value problem. Now every differential equation represents some kind of physical phenomena. For example, if a car is traveling on a road, and its change in rate of change of displacement is proportional to its displacement at any time t, then if we solve this expression and change the sign of proportionality with a sign of equality, we have to put some kind of arbitrary constant like k here. So it is a differential equation. So if we solve this differential equation, we can easily separate the variables. This kind of differential equation is called variable separable differential equation. Now to solve the above expression, we have to integrate both sides. So when we integrate the above expression, we get the solution like this: log of x is equal to kt plus some constant. This constant is involved whenever we integrate some expressions. So x is equal to e power kt plus c, and e power c multiplied by e power kt. We write the above expression like this, and if we put the constant e power c name as c1, this is the solution of this differential equation. So every differential equation represents any physical phenomena, and whenever we solve a differential equation, we get a solution like this. The solution involves an unknown constant, and the value of this unknown constant can be found by giving some conditions along with this differential equation. If the conditions along a differential equation are given on only one value of independent variable, here the independent variable is t. If there is a condition like x at 0 is equal to 5, it means that at time t is equal to 0, the body is at distance 5 units. If we put this condition in the general solution, in this solution of differential equation, then we can get a particular value of the solution. The condition here along this differential equation is only at one value of independent variable, then it is called an initial condition. If the condition along a differential equation are at more than two values of an independent variable involved in the differential equation, then it is called a boundary value problem. So we are going to solve an initial value problem, but we have defined that what is an initial value problem and what is a boundary value problem. So we can say that initial value problem, differential equation attached with only one initial condition or only one value of independent variable, and if the variable's value, independent variable's value, is more than one values of independent variables, like we can say that we have a differential equation like this: d square y by dx square plus k dy by dx plus y is equal to e power x. That is a second order differential equation. You should clear one thing here, that when I solved this differential equation, it was of first order differential equation. Dx by dt is equal to kx. It was the differential equation which I have solved there. Then because the order of this differential equation is 1, so there was only one arbitrary or unknown constant involved the solution. Now it is a second order differential equation. When we solve this differential equation, there must be two unknown constants involved in the solution. So there should be two conditions along this differential equation. If these conditions are only at one value of x, means independent variable, like these two conditions, y at 0 and y dash at 0 is equal to 2, if this differential equation is attached with the conditions which have only one value of independent variable x, which is 0, then such kind of differential equation along these conditions is an initial value problem. But if we have more than one value of independent variable involved here, like y at 0 is equal to 1 and y at 1 is equal to 2, then such kind of differential equation is called a boundary value problem. So I think so that you must clear what is the difference between an initial value problem and boundary value problem. And now I am going towards the general solution of this differential equation which I have solved earlier. Because there is an unknown constant involved, the solution, such kind of solution is called general solution. So if someone say what is a general solution of a differential equation, then the solution of the differential equation in which unknown constants are involved, then such kind of solution is called a general solution. And you know that from this solution I can get the value of this differential equation. Again, we can check the solution is correct or not. We can get back the differential equation from this solution. We can check it. And one thing I want to add here with the general solution, that if there is any kind of condition given along this differential equation like this, then if we put the condition in the solution of this differential equation, x at 0 is equal to 5, we get the expression like this, that t is equal to 0 and x is equal to 5. We get an expression like this. So unknown constant is now solved and we get the value of c1 is equal to 5. So the equation star now get the value x is equal to 5 e power kt. So this is another solution of this differential equation, but this solution is for some particular value of the variables involved. So this solution is called a particular solution. And this solution, because in involvement of some unknown constant, is called a general solution. So you should clear 4 things here in my lecture today, that what is initial value problem,